Suppose we start. Sorry, 10 minutes to wait. Sorry for the delay. It never works when you need it. I suppose people who are still enjoying the coffee can hear me or not interesting. Yeah. So, first of all, it's not really about Scala. It's kind of about Scala because it's implemented in Scala and it generates Scala code. But it's more about REST and microservices. And as we already seen today, a couple of questions were mentioned already, like those, and I would kind of like to pick up on these ways and maybe be able to answer them. I would really encourage you to interrupt me and ask questions during the talk, because I'm going to say a couple of controversial stuff, and don't wait to express your anger if you like to. I maybe will even drop the microphone and just talk out loud. That's best if you can hear me. Is it okay like that? Can you hear me? Yeah. Okay. Then let's continue without that. So, a mandatory introduction about me. That's me. That's my history of life. And so currently I'm working as a Scala consultant in Germany for the last couple of months. I'm consulting a big company, big online shop, Zalando. Who knows about Zalando? Wow, somebody even knows. That's very surprising because usually you see nobody raising the hand. Zalando is a very big online shop, and their online shop for fashion articles. They have many offices around the world, about 1,000 developers in Berlin office, and by the way, they constantly hiring. If you want to work in Berlin, talk to me after the talk. Yeah. So the interesting stuff about Zalando, they realize microservice-based architecture and approach in general. So they have multiple small teams which own their stuff they develop. They autonomous, small, they have full responsibility of what they're doing, and they really own some components they develop. Which means they interact with other developers inside of this company. Like that's only tens, every 10 colleagues, but you can imagine how it is. And those are teams, right? It's me. So let's look closer and about what happens in the point where they interact. That's actually boundary between services. So in order to be able to develop those services quickly, we really need those teams to be able to do this independently from each other. But they can do anything they want. As soon as they don't break records in the community, they can do their stuff. How we can do this? How can we achieve that they actually can start develop from both sides independently from each other? Once again, that's what we want. How we do this? We came up with a very first approach. Basically, that's very simple. We say we don't do anything until we agree about what we actually want to build. So we document and we review the API before we write any code. So and ideally, if the API is good enough, if it's specified good enough, we should be able to do this stuff on the right side of the line. So that goes like that. Those guys came up with the specification, and another team, they reviewed the specification. As soon as they agree that they're happy with this specification, then misinterpret in their own way and start to build the stuff. They implement server, they implement client, everybody's happy. So actually, we can start to implement the server, and we can write tests which are conformed to this line. And on this side will be the same. So now that's dry principle from Dave Thomas. That's another pragmatic programmer, if I remember correctly. And he was actually angry about the understanding of dry, like you should not copy paste the code, because what he meant was totally different stuff, which is in green here, right? Means the specification which we came up with after all of those conversations and so on is a software. It should be treated as a software, and it should be a single source of truth for the whole system. What does it mean? Let's pretend this is a nice, beautiful specification and place it into the space of all possible implementations of some software, right? And one implementation would be a plane on this space. Like, given this specification, we can say, can you see that? Those planes. Probably cannot, right? Sorry for that. So actually you can see that from all of those planes you can choose those crossing the specification point. But it's infinitely many of them. As soon as you choose architectural style, which this specification should confirm, you can constrain your planes like to those who are crossing the line among those two squares or points. And as soon as you decide the technological step, it's kind of only single plane can cross all of those 3 points. Or like if there's no points but spheres, then it might be many of them, but they will be very similar. They will be placed like very narrow. And yeah, only one. Here, I see everything. So he said architectural style must be REST. Why REST? Yeah, everybody's doing that. No brainer. Who can choose anything else now for building systems which should be interoperable and not tightly coupled? So we choose REST because of all of this stuff, and take a look precisely. Those are in bigger font. They're actually technical details. We are not really concerned with them, not partly, but not really. If we develop our RESTful microservice. So what we are interested in mostly in those two. And in this place, I think I just need to call this guy, who is inventor of REST. And I think it was like 8 years ago, he wrote a really I would say that was a blog post where he described how REST is misunderstood. And I would read this, but the main point is it should be hypertext driven. Right? So this, we're coming to the question: who is here familiar with REST? Oh, REST, sorry, with Swagger. Wow. Funny stuff. Last time I presented in Java conference, I saw like 3 hands in the question. Who is familiar with Swagger, and 1 hand who is familiar with Play. So it's really good. Who is using Swagger to generate client code? Yeah, you won't like me. Why? I will tell you later. So how is REST and the API calls interoperate? But can we use them together at all? So basically, what looks like the conversation between server and client, really RESTful conversation. Client comes up with some resource representation which it sends to the server in order to change some resource. The server responds with another representation of the same resource and some hypermedia which actually describe possible state transitions. This client, what can be done in the future. And that's it. And the client then repeats. So what can we see here? The hypermedia control should describe what client is supposed to be able to do, not the client which is generated from Swagger specification. That's actually even crazier stuff people do. They use documentation notations. They place Swagger documentation notations into the implementation and generate documentation from that. that's actually can be done, but it shouldn't be done. Right? It should be named REST as well, because that is the core feature of hypermedia control applications. Coming back to microservices. So I would just change the notion from those circles to hexagons, also known as ports and adapters. It's just usual way to represent those services. And this notion was introduced 10 years ago, I think, by this guy. And the main point is those are services, they communicate over edges, and they all have layers, like outer layers, like framework, you cannot do this, application, domain, codomain. The deeper you are, the more framework and kind of outer stuff independent you are, and the more specific you are related to the domain you're programming. So our microservices and teams would be like that. Those are not bees, those are developers, and the services themselves would have those layers. We have those layers, those two of them, let's color. This is a boundary. The orange stuff is actually the specification which describes what should happen on the place where they operate. I'm loud enough, can you hear me still? Okay. So basically, as soon as we have this specified, if you remember about those key points, you couldn't see it earlier. And as I said, there's actually only one possible, or almost only one possible implementation, given those three constraints. You can see that the outer layer will be some transport layer like HTTP, REST-related JSON marshalling, whatever. The next layer will be some kind of validations, which will make sure that our domain is sound, and for some specifications, they actually define the model in the way that you cannot do the definition in different ways. So this gray stuff, the stuff is very brown. It's almost defined in a single way from the specification if it's detailed enough. So that as a programmer, I don't want to care about what's happening in these various areas. I want to invest my efforts in programming real features which is happening in the domain. And to be less abstract, what does everything to do with the real world? So we take Swagger, which is really easy to use. Actually, it's not a good choice for RESTful APIs. As this is a really client-based, and those guys, they really say, yeah, we actually don't care what you do on your server side. We developed this standard to generate clients. And yeah, but it's good enough. And we take free. Yeah, I had type safe here before, but now it's gone. For those reasons, yeah, those who use Swagger, they already know those are features. For others, it's probably not really interesting. And what can we do with that? So the structure of Swagger specifications, like you have different areas like security-related definitions, where you can describe different complex types used by API calls, and an API call area where you define different URLs, different HTTP verbs and parameters which can be used to reach those specific calls. And out of that, turns out it's actually possible to generate layers, marshallers for your JSON or whatever you want. Play controllers, and not really play specific, but still play validations, and absolutely not play specific tests which are driven by test data, Scala model, and some security stuff. So, about test data. So what is it? How come we have this stuff, and here is secure test data. Easy. So, complete test, basically, it comes out of the fact that by testing you cannot prove that the program is correct. You can prove that it's incorrect. But usually you cannot prove that it's correct. And from this concept was born this one, property-based testing, which uses the notion of type and uses in the way that it says that type actually specifies what is possible. So what is possible, how the variable of some type should look like. Just specific rules which the variable should comply to. And out of that, we can actually generate variables of some type and check if they comply with those rules. Yeah, then this is a variable of this type. It comes out of Haskell's community. I think also almost 10 years old. But yeah, concrete in Scala mode, we can, for example, have provable types, which we can really say there are only those values possible, like true or false, equal or not equal, and those things. And in this case, if we have only provable types in our API definitions, it's actually possible to really prove that the program is correct. There is no possible inputs which can drive the program to behave incorrectly if all tests pass. And some which is falsifiable, you can really generate inputs until it fails. And from those you can construct pretty much anything. Any complex type can be built from those guys. And if you wondering what this everything has to do with Scala, then actually you're right. Less than expected. Actually, it has nothing to do, or not as much to do with Swagger either. It's mostly about REST, mostly about definition of the API. And because of this is a plugin architecture we have. This is a currently it's play plugin, and it takes the Swagger specification and parses it to the AST, which is not abstract syntax tree. It's an API syntax tree, and then we generate layered parsers. Currently, we're working on API support. Turns out it's easier than we thought initially, and those guys might be implemented in the future. Depends upon how much interest will be shown to the plugin itself. Yeah, I will try to show you what it looks like, feels like. I hope. Can you hear me? Yeah. Okay. So I recorded a short script because of the, I would say, what it is of Wi-Fi connection here. So that's just how you can create a new PlaySwagger project. Yeah, you won't be able to see this in Dynamics, but actually you say activator. Speaking here, is it readable? Right? So you say activator. So activate. So clicking here, you test create work, and then it generates an activator template, and we start this BT, and it loads the internet, which I don't want to do now. And then I actually get in the template itself. There is only single file present, except the infrastructure. It's a specification, and as soon as I issue this test comment, I get certain Scala files, one Java source, and two Scala sources into the tests generated. And the test runs, and it says, okay, I see that your API actually don't accept the invalid data, but you probably should do something with your implementation because it doesn't return expected results for valid data. That's it. So that works out of the box for just a single YAML file. I will show to you how it looks like. So my Mac crashed just before the presentation, so I probably will need to reopen all the stuff, all the tabs. Yeah, yeah, that's a wrong one. So probably the easiest way to save time, I will just switch to another project and continue on there. Yeah, online shop. So we want to play with parcels. To give some context, so I want to have a parcel which is first packaged, then it handed over to some transporter, it's transported to the receiver, it handed over to the receiver, and then it's received. So this package goes over a couple of steps, and I can model this in different ways. For example, this is a very, maybe I can make it even like that. Is it okay? Yeah. So it's kind of metadata which is not interesting. I can model it like I can have parcel with ID, and those are states that the parcel goes over, and then I have parameters ID and the parcel, which is in the body, and that can happen as a response, and then I can get this parcel. So it actually, the definition of the parcel itself, it has following properties, following types, blah blah, nothing special. So basically, the server just accepts something which client posts to it, to this post, and then it changes the state of the parcel accordingly. So that's actually the whole specification. It's completely incomplete, but already with that we can kind of do following. No, that's bad. So out from, if I would start compile or run or something like that, it would generate following. I already did this because, as I said, I didn't want the SBT to download the internet. That's a controller. You have failing implementations here for your get method and for your post method, and you have a parcel type and a longer ID. This was defined in the specification, and all heavy lifting actually is done here in generator code. So in the generated code, you have some model classes, like this parcel, which has all the properties which were defined, and all the type definitions. You can have some validations, like those are really huge files, but like that, the ID must be at least 5 and not less. And we can have some test generators. Actually, the test generator for parcel generates some arbitrary stuff and then returns the parcel to the test itself. Yeah, and then you can model this in different way. I won't show you the specification. It's quite lengthy, and I will just maybe show you the Swagger API. So as I said, I didn't write any single line of code yet. And if it's not downloading, it's compiling. So nobody wants to interrupt me in that sound. Please. Yeah.
All this stuff working electronic, so we change our API, generate.
Yeah, that's a point. That's a point. So there are two kinds of artifacts, actually three kinds of artifacts, which are generated. The first one is the stuff which is completely related to the specification. And it's then generated after each change in the specification itself. The second type of artifacts is something like this controller. Give me a second to find it. Those are types. This is a controller, and those nasty comments, they actually really matters. If you change something, this stuff gets completely generated, but all your code you have written again is there preserved. And some stuff generated only once, and you need to issue a command like Swagger security, or maybe I can show you this one. And this generates stuff like security extractors, because it's really important that you notice the changes that made to those components, and nothing changed explicitly in those areas. Yeah, back. So now I have this Swagger API, this post, and get, and I actually can really try to get something. I probably, for this one, I probably will get something like, do I have this? Of course I should have some, that's a demo, it's expected to be like that. Yeah, not implemented error. That's actually this failure I'm returning. Yeah. And if I, for example, now change the specification, like for the get method, I want my ID to have a minimum value of 5. And yeah, thanks. Then if I try 0. Now it will generate related components again. And now it's only 8, so nothing changed. And here we go. So actually, I didn't touch the code at all. And we have a couple of validators for everything you can imagine, including regex, whatever you like. You can, the same way you can add security. Currently, OAuth2 basic security and API token supported, because they are supported by Swagger itself. What you can now do else, and that's related to the topic of hypermedia. So I will just take it from here. You can put the description of the transitions which the parcel going over, and you can, among other stuff, you can say, oh, give me a state diagram. And if you're really curious, you can, for example, put it into graphics. Yeah, that's what we have in our system. Yeah. I forgot that from loss the package can be actually found and be delivered further. Then we need to state it explicitly. Okay, let's add one more transition. Can be moving again. I took it from that. Yeah, here we go. The point behind this state diagram is basically useless per se, but it gives us the possibility to generate hypermedia control. We're not doing it in every case now. It's kind of a feature under development, but the idea is that as a programmer, you kind of just specify what's possible, and then you can use whatever you want related to hypermedia standards. and the system just picks up your stuff and does the rest. So I didn't show you those transitions you see here, like those. In the version of specification, I've shown you they are triggered by the client. But the proper way to implement it RESTfully would be to create additional resources, like if it headed over to transporter, then probably some kind of tracking number might be given. And then it's moving, then the tracking number is changing. And then it's destroyed, then probably there must be some document about that. And you can model this in, using kind of this kind of specification. That I would say less than 200 lines. No, that's more than 200 lines of code. Okay. Almost 300 lines. But then for that you just go. Sorry. I'm running. You just go change the way you want to do this, and now you have basically the same parcel traveling, but you can change its state using completely different API calls. And the funny stuff is I actually just compiled it, and yeah, this is my model for this, for all of those calls. So this is a tracking, this is a recipe for the parcel. This is an accident statement in the case if something happens. And those are really strong types things. So you can have options if it's not required, and so on. And they are validated. You have your controller with all of those methods, these types, how you specified it, defined for you. Yeah. So basically, if you have questions how some specific things could be done, please ask. Otherwise, yeah, that's it. Yep.
This can generate client side.
Sorry?
Can this tool generate the client side?
Oh, yeah, we could, but we don't want to, because of the reasons I was talking about. So basically, if you take a look at so now from this side, as soon as we have this, you can do whatever you want on this side. And if you really want to implement it, we're actually talking about implementing Java Play plugins for a couple of weeks with some developers. And we had talks about implementing this not as an SBT plugin at all, but just in the way Spring Rule does the stuff. For this, if you really want to take a look how to do this, we have let me see. We have a possibility to output the parts of the tree. It looks like that. So we have passes, definitions, and that's a part of the ST related to type definitions for each specification present. The same thing can be done for parameters, for example, less than types. And yeah, we have a couple of processing steps in the compiler, in the ST compiler, and you basically, if you want to write a parser for some specification standard, then you can take a look what is expected on this side. And then we take care about flagging the types and all of this boring stuff. Is it answering your question? Yeah. One more, please. We use it in production in Zalando. But yeah, we have a privilege, or kind of privilege, that we really decide by ourselves how it runs. So if the team decides that they need 3 more months for something before they go in production, they will usually get this time. So to be honest, currently it works like that. We just get some error messages sent by colleagues who are using this, and then we fix the stuff. But currently we have version 0.17. It's stable enough almost for any specification we could find as an example of Slider specification.
You rely heavily on Play framework, so you are fully Scala shop is exclusive Play.
Kind of, and yeah. So why Play? Oh, because it has continuous recompilation. That's really useful. So basically, if I'm developing, I'm kind of just hit the run command, and I constantly changing my specification, and I immediately have this code generated. Why Scala? Because it offers really very much flexibility in how we can generate stuff. I could imagine in Java it would be probably twice or 3 times as much code, and it will be more complex. So it's no-brainer to start with easy stuff and then take a look at other. But as I said, actually we're not really bound by Play, we're not really bound by Scala, we're even not really bound by UCT. But all of those provide useful infrastructure kind of to start with.
You said that it's not a proper way to generate clients, but I'm missing the point. What is proper way?
The proper way to describe your RESTful API. The proper way to describe. So why are we generating the server side? Yeah. Because here you can really see that the server doesn't expect anything except the resource representation. So basically, the server must understand what is sent, but the client must understand what can be done next. And for this, the REST says there is proper way to do this is hypermedia controls. So you actually must use link relations to describe what should be done, what can be done as next. And actually, to be completely honest, we shouldn't even use this this part, the definitions part. That's cheating. We should define MIME types. The MIME type, for example, for parcel, the MIME type for receipt, the MIME type for tracking, and just return those MIME types. And client and server should have sharing understanding what specific MIME type is, how it should be worked with. So basically, you don't have the specification which is human readable. You have MIME types, you have link relations, and that's it. That should be sufficient for the client. And that's the proper way to decouple server and client. Because let's go back to the questions. Right, Akka versus microservices. That was a question here. I think the guy got it. Yeah. So
When you pause them.
yeah, the point behind microservices is decouple systems. If you use Akka, you decouple systems. So you kind of, yeah, in the same way you can say, let's take OSGI, define our interfaces, and implement everything against those interfaces. What's the difference? OSGI has remote service calls. Yeah, you can distribute the stuff. Why not? So that if you have Akka on both sides, you don't have enough flexibility for one of the teams, for example, to choose Clojure or to choose Ruby or implement it with assembler. And that could be the case actually if they want. So proper contract testing, yeah, as I said, if we have a proper contract, then we can test it using property-based testing. The forward-backward compatibility, and that's what it's really huge discussions. Should we add a version number to our URL or not? And then have months of conversations about it. Because you can do anything you want, but actually you should be able to just generate random URLs at runtime and attach a meaning to those URLs through the relation types, and then the client should be able to understand what this URL means without relying on the structure of the URL. So, and in this sense, even the question about version or not version, is not about REST. Yeah, it's about HTTP. Yeah, that's connected to MIME types. So if you have proper MIME type definition, then you should be able to process this almost in a semi-automatic way, because MIME types designed into machine vision. Yeah, and Ruby itself is kind of what my whole talk is about.
What does support XML? Do you support it as well?
XML is instead of JSON.
Yeah.
So currently we don't have any marshals for that, but I think if it's really needed, it can be added in a couple of hours. Any other questions? Yeah, then thank you very much for your time.